Okay, so here we're going to talk about this problem now. 3.12, and please read the problem statement first. I didn't touch anything, just jumped. Okay, do you guys finish reading? Okay, so let's read this together. So this company manufactured this heavy heavy-duty air compressors. Okay, and they're trying to plan its production for the next 6 months. Okay, so that's their planning horizon. Because of seasonal fluctuations in utility and raw material cost, those unit costs of producing and the demand vary from time to time, from month to month, as you can see from this table here. And production capacity also varies from month to month due to differences in number of working days. So that's here, the maximum production capacity here show. Okay, and so this table summarizes all those 3 different things: that the unit production cost, units demanded, and the capacity in each of the months. Okay. Given the size of Upton's warehouse, a maximum of 6,000 units can be held in inventory at the end of any month. So maximum. So the keyword here, maximum, that means we need some constraints here. Okay. The owner of the company likes to keep at least 1,500 units in inventory as safety stock to meet unexpected demand contingencies. To maintain a stable workforce, the company wants to produce no less than 1/2 of its maximum production capacity each month. Okay, no less than. Upton's controller estimates that the cost of carrying a unit inventory in any given month is approximately equal to 1.5% of the unit production cost. So that's the inventory cost. Upton estimates the number of units carried in inventory each month by averaging the beginning and ending inventory for each month. So that's telling us how to calculate this inventory, average inventory, and then the inventory cost. There are 2,750 units currently in the inventory, and they want to identify the production and inventory plan for the next 6 months that will meet the expected demand each month while minimizing production and inventory cost. Okay, so we went through this key information once. Okay, and let's think about, okay, what's the decision here? Or what do they want to do? Okay, so this is our decision, right? That's the decision. And the decision contains two parts: how many to produce and how many to put in the inventory. Okay, and what's the objective? Minimize production and the inventory cost. Okay, a few of you are IEs here. Let me ask you, what's the relationship between production and the inventory? And maybe demand. No, the production and the inventory and the demand. Think about what's the relationship. Okay.
Production minus inventory goes to demand is equal to
Production. Okay. What's that?
Production minus demand goes to
Okay, good. And that's assuming you don't have any inventory at the beginning, right?
Yeah.
But if you have beginning inventory, what happens?
Then if there is no production, then the inventory will be
Okay. And usually we need to differentiate it between if it's the beginning of the month or the end of the month, right? And what Zarka said is the end of the month, right? So let's see. Inventory. I'll use the I to represent it. Okay. Inventory. Oh. Nah, maybe I should use a different thing. But these two I are different. Okay. Inventory at the end of month I equals to be the beginning inventory, which means it's the inventory at the end of the previous month. Think about it again, right? Okay, so that's the inventory at the end of the previous month plus whatever you produce that month. Okay, right? Minus the demand of that month. Okay, and here we are saying this inventory is the end inventory. Okay, so that's the inventory at the end of month I is II. Okay, and production. Sorry, I defined it the other way. I should put II is this. So production in month I is defined as the PI, and demand in month I is this PI here. Good. So that's the relationship here. Okay, some initial analysis. Okay, then let's go back. These are those summaries. Okay. So we talk about, okay, here. That's me. So identify the production and then pre-plan. So let's just define the decision variables first. since our plan is to know how much to produce and how much to put in inventory. And we already know the demand. Based on that formula we just talked about, if we can calculate P from this OR model, do we know I? We know I, right? We cannot define both P and I as decision variables because there is a relationship between them. Is this clear? Because of that relationship, here, let's go back to, because of this relationship, if my P is defined as the decision variables, then this I will be calculated depending on this formula here. Okay, because we know this I here, we know the D here, and we know the beginning inventory at the very beginning. Okay, so once we define this as the decision variable, we will be able to calculate this inventory. But still, we're going to use a variable to represent this I because it makes it clear, make it easier to model. Okay, although it is not a decision variable, which means that when you implement this in solver, you will only highlight the variables, the cells. You will only leave the cells blank for the decision variable when it represents the P part, and the I's need to be in the formula like this. Okay, so the I equals to be the beginning inventory from the first month, and then when you calculate that inventory of the second month, then you refer to that there. Plus the decision variable cells, you refer to the decision variable cells minus the demand which are given. Okay, so those I's won't be decision variables. You won't leave them blank. Instead, you put a formula there. Okay, hope this is clear. Then here, so my decision variables will be just the PI. Represents the unit of air compressor, right? To use in Okay, so that's the only decision variable. Okay, but also we define I as the ending inventory in month I. So this is a variable that helps us to make the model simpler. Okay, but it's not a decision variable. That's why I just put it here. So this I'm just put a parenthesis here. Okay, then let's look at the objective function. We know that we want to minimize the production and the inventory cost. Okay, so here I'm not writing the function yet. So that's the minimize. Let me just go back to this note page again. So we want to minimize total production plus inventory cost. Okay, so production cost is easy. It's the unit you produce, right? Because in that table, the unit production cost is given. Okay, so that would be PI multiply that's CPI. These are the unit cost, unit production cost. It goes from 1 to 6. Okay, and this part would be the inventory cost. And we do have the cost of inventory in the same table again. So here, we have here they calculate the cost of inventory in any given month approximately 1.5% of the unit production cost. So that means we can calculate, we can maybe add a row here just to calculate the inventory cost being 1.5% multiply the row above being the inventory cost. Okay. Unit cost. Okay. Then what we need to pay attention here is that should we use the ending inventory or the beginning inventory or the average inventory when we calculate this inventory cost? So here you can see they estimate the number of units carried in inventory each month by averaging the beginning and ending inventory for each month. Okay, so that means to calculate this inventory cost, it's not the beginning or the ending inventory, should be the average inventory. That makes sense too, right? It depends on on average how many units is carried. Okay, then where do we find this average inventory? Okay, so since we define this I as the ending inventory, and in this note here we already used this ending inventory and the beginning inventory. So here would be the beginning inventory of that month, right? Plus the ending inventory of that month. So this part is the average inventory. Okay, multiply that cost, and this cost is 1.5% of the production cost in that month. Okay, so with that we got these two parts of our objective function. So I'm just going to go back to define here. So that would be pretty big. And if you would like to define another decision variable to if you want to define another variable just to represent the average inventory, so that the objective function is less longer. No, is not that long. You can do the same. Okay. So for example, you can define. I'll show you the two ways. Okay, so here you define this, and define IN as the average inventory in month I. Then in your objective function here, you don't have to write this out, you will just have this IN multiply this CIN. So the objective function won't be that long. So either way works. Now let me go back to here. Okay, so you guys all have the problem statement, right? So we'll just write the objective function here. So we want to minimize, or write the production cost first. So that would be the 240 P1 plus 250 P2 plus 260 times P3 plus 285 280 plus 260 P6. So that's the production cost part. I'll put them in parentheses so just to differentiate. Plus, because the inventory cost is just the 1.5% of the unit cost, I'll put this 1.5% out of this big parenthesis, so I don't have to write it for every month. Okay, so this multiply 240. I use the way I defined the average inventory. Okay, plus 250 IN2 plus this is the same coefficient. Oh. It's the same coefficient as above. So just change the P to the IN. Plus 285. 280. Plus 260. Okay. And first thing what I'm going to do will be to define this IN. So IN1 equals to be, that's the average inventory in the first month. Okay, and we know that there are currently 2,750 inventory currently there. That means that's the beginning inventory. So that would be 2750 plus I1. That's what we defined as the ending inventory. Okay, divided by 2. And after that, they will take the same format. I'll just use I to represent. Otherwise, we're going to write 6 formulas. Okay, one for each of the average inventory. But here I'll just use this I to represent it. Equals to be I minus 1. Or you can do this for all of them. Just define the first equals to be 2750. But here we'll just do I divided by 2. For all I goes from 2. Yeah, if we want to apply to this one, we'll go from 1. Otherwise, we'll go to 2, 3, to 6. Okay. Or the other way to write this would be for this I equals to be 2 minus 1 plus 2. For all I that goes from 1 all the way to 6, and I0 equals to be 2750. So either way works to define the average inventory right here. Okay, or the other way to write this entire thing would be, of course we'll have other constraints. Okay, the other way would be to minimize. So the first parenthesis, I'm not going to write it, that's the production part, plus 1.5%. Then you write 240 times 2750 plus I1 plus 250 times I1 plus I2 plus 265 times I2 I3 plus all the way to 260 times 2 I5 plus I6. Okay, so this part is exactly the same as what I wrote for this entire part. So just depends on where you want to save some space. Say if you want your objective function to be not that long, then you use a variable to represent this average inventory and just define the average inventory using the variables you define. Okay, otherwise you just write this entire object function in this way. Clear? Okay, then besides those constraints, so if we use this way, first we need to define the average inventory being a relation of the ending inventory and the beginning inventory of that month. Okay, then continue. Let me just write those. Okay, so I'm going to leave just this part here. Okay, with because this formula here defines the relationship between your beginning inventory, end inventory, production, and the demand. So that's another formula that we need to include in your constraints. Okay, without this, even though it does not say that, okay, this have to be less than equal to something, greater than equal to something, this defines the relationship between your variables. Without this formula, the model won't solve. So it's kind of not, it's not regarded as like a constraint as the other ones, but still you have to put it here because this defines the variable relationship. It's kind of like, okay, the sum of your variables need to be something. Here we have to write, okay, so yeah, let's just use this way. We'll just use this as the constraint, and we will put this for all I goes from 1 to 6. Okay, and you will have to write out your D's, because P is a decision variable, I is a variable, but D is not a variable. Okay, D are given, the D's are given. So D1 equals to be the unit demanded, 1000. D2 equals to be 4500. D3 equals to be 6000. D4 equals to be 5500. D5 equals to be 3500. And D6 equals to be 4000. Okay, so these two together define the second group of constraints, which is the relationship between your beginning end inventory and production demand. Okay. Now with those relationships defined, then we can go back to look at those other constraints. Okay, so we did use the unit cost, unit demanded we used, then the maximum demand production. So that's the capacity. That means the PIs need to be less than or equal to those ones. You cannot produce more than the capacity of that mass. Okay, so the third constraint. So this is the second one. Third constraint. Another big group. Okay, so P1 needs to be less than or equal to 4000. P2 less than or equal to 3500. P3 less than or equal to 4000. P4 less than or equal to 4500. P5, P6. Okay, so that's the third group of constraints. Maximum production used. Okay. And then this one. A maximum of 6000 can be held inventory at the end of any month. So that's another constraint. That's for the ending inventory. So the ending inventory needs to be less than or equal to 6000. The fourth group, I'll just use I to represent this instead of writing 6 constraint down. Okay, because the right hand side are the same. Right hand side are all less than or equal to 6000. That's for the inventory part. So that's for all I go from 1 to 6. As a fourth constraint. Okay, check. or to keep at least 1,500 unit inventory as safety stock. So besides this less than equal to, we also need a greater than equal to. The fifth one. This II also need to be greater than equal to 1500 or I. Now that's the this constraint here, 1500. The company wants to produce no less than 1/2 of its maximum production capacity each month. Okay, just now we took care of this constraint. That's you don't produce more than these ones, and here they want to produce no less than half of those ones. So that means for all the p's we have another side to write. That's half of. So all of these ones, I'm just going to add on this side. 2,000. What's this one? 1750. Okay, and this one 2,000. This one 2250. 2,000. Okay, so that's constraint 3 and 4. So for the production, you need both sides to be there. And that took care of this constraint here. Okay, and we've already talked about this. That's calculating the inventory cost. Done. We use this value. Done. We did use this to define the decision variable and the objective. Okay. So that's the model for this problem. And the main thing for this problem is that when you calculate the inventory cost, they use this average inventory. Okay, but when you need to define the relationship between the production demand, you need to use the ending inventory. Some students confuse those together, so they use one variable here, just this I, and when they do the inventory cost, they just use the I instead of the average inventory. So that's one place to be cautious about. And the other thing is that since in the objective function we use average inventory, some students started with define the average inventory as the direct variable to be used, and they use this in here as the variable, and when they try to define this relationship here, they try to use this in, which is the average inventory, and don't know how to formulate this relationship. Okay, so you see it's more straightforward to define these I first being the ending inventory, and use those I to calculate the average inventory, instead of defining the average inventory first and try to calculate the ending inventory, because there's no way to calculate the ending inventory from the average inventory. So the relationship the other way. Think if it makes sense. Okay, so if we start with this I here, the beginning ending inventory, it's very easy to get the average inventory. But you start from average inventory, try to represent those ending inventory using the average inventory you define. There is no way to do that. Okay, so that's the things that need to be take care of. And in this problem, because the p's already have its lower bound, so the decision variables, usually we need to add a non-negativity constraint for our decision variables, right? But in this case, all the decision variables have lower bounds, greater than or equal to 0. So we don't need that non-negativity constraint in this case. So that's our model. Okay, and so in the slide, I defined, I used the B to represent the beginning inventory. Slightly different as what we talked about, so yet another way to define that. And so instead of using I minus 1 and I, here the inventory is defined as the beginning inventory, so it's kind of like I and I plus 1 here. because the B is represented the beginning inventory, and in the model we just defined is the end inventory. Okay, so it's like BI plus BI plus 1 being the average inventory. Inventory in month I. Okay, and use the long objective function, and those values are already calculated using the 1.5% multiply those rates. And the production level already talked about them. The capacity and half of the capacity in each month. And the inventory, instead of using the I replace that inventory using the actual formula here. So let me go back. So what I wrote here is equal to, let's say 1500 less than equal to B2 less than equal to 6, and B2 equals to B1 plus U1 minus 1000. So these two together can replace this formula here. Okay, make sense? But this way is easier because you don't put a lot of the formula in your constraint itself. Okay, you just put this one variable here and define what that variable is. And other constraint, yeah, here that's you define the other constraints. Okay, so this problem is also a little complex to implement. See, let's implement it. So you can just use the go back to the spreadsheet I asked you to download. Click on the production part. I put those data here for you already. So we know that the decision variables are how many to produce each month. So oops, let me just move those ones down a little bit. Okay, and I'll put to type here. Okay, so put let me go back to here again. Oh, I discussed my notes already. But remember, like there is a form here. There is a relationship that we defined here. So in that spreadsheet, I want to define that I want the spreadsheet to represent the same thing. So we'll have the beginning inventory plus the decision variables, which are the unit to produce, minus the demand. Okay, so we'll have the 3 rows. So here I will have make it line this way. Okay, and then we'll have unit produce. Okay, I'm just going to delete this row here. Yeah, I just deleted that entire column and just move this. Okay. So we have beginning inventory, unit produced. Remember we have beginning equals to be the beginning inventory plus unit produced minus what? Unit demand, right? Okay, which is given here.
Yeah.
Okay, so let's just move this. Move this entire row here. Okay. That equals to be the N thing inventory. Okay. And those units produced are my decision variables. I'm going to highlight those first. Okay, so you got this, and oh, here, need border here too. Then first thing would be to put that the beginning inventory, which is 2750. That's given. Okay, then put the formula here because I want to define those relationships first. Okay, different from the other ones, we do like in other models we do the decision variables and then we go to the objective function. In this case, we need some other values to calculate the objective function. So I'll define those relationships first. So here, ending inventory equals to be beginning inventory, right? Plus unit produced minus unit demanded. Yeah, let me enlarge this part. Okay. And for this one, you can copy it all the way here. Just click. Say, okay, it's the beginning inventory plus unit produced minus demand. Okay. And then there is another relationship we need to establish, which is the ending inventory of the first month equals to be the beginning inventory of the second month. Right? Okay, so here we need to put this equals to be this here. So that the relationship is defined. Okay, and that's the same for all of them. Just copy it all the way. Click inside. Okay, so this beginning inventory of month 6 equals to be the ending inventory of month 5. So this cell here always equals to be the ending inventory of the previous month. You do it here, then copy it all the way. So with that, we took care of the relationship between the inventory, beginning inventory, unit produced, the demand, and the inventory. Ending inventory of 1 month versus the beginning inventory of the next month. Okay, so these tables are done. Okay, now we know that our objective function needs us to, need us to calculate first the production cost and second the inventory cost. Okay, and I'll put a place to calculate the. See, so that's the unit production cost. So I'm going to move this. Move this down a little bit. Okay, unit production cost. because the inventory cost is 1.5%. I'll put the unit inventory cost here. That is, oh, I know why I had that one column inserted, because I need to put that 1.5% here. So let me just add this back. Insert. Oh, sorry. Okay. So I'll put that 1.5%. Make those equals to be this one times this one. And I want to fix this. I want to fix this cell here, so I put the dollar sign. Click F4 and it will fix it. Then all the way. Copy it all the way to here. With that, I got my unit production cost. Okay, then I know in my objective function I need to get the sum product of the production cost versus this unit produced. But I also need a row that represents the average inventory, so I can take the sum product. Okay, so what I'm going to do here, I'll calculate. Let me just put variable. Yeah, actually, I would like to put that average inventory somewhere here, but yeah, let's just do it. We'll do it here first and then move, if there is a better place for it to go. Insert. Okay. So here, I'll put average inventory. And this equals to be beginning inventory plus ending inventory divided by 2. Copy the other way, so that's oh, did I? Oops. Oh, right. We don't have an average inventory at the. Let me see. This one is the average inventory. Oh, I think because this is the beginning.
Yeah, so it's not E7.
Right. Yeah. This should be here. Sorry. Yeah, it's these two.
Yeah.
Thank you. It's the beginning inventory and the ending inventory. Okay, so let's copy this one instead. So yeah, it's the beginning inventory and the ending inventory. That helps calculate the average inventory. I'm going to insert a row here, just for myself, because the reason is because these four are closely related. We calculate them using this relationship. This plus this minus this equals to this. And average inventory, I just put a row, just for myself to differentiate. Okay, then we got those unit cost, inventory cost. Now I just put that production cost and inventory cost. Equal to be. Either way, you can calculate the monthly production cost, monthly inventory cost, and add them together in one cell, or you just do the sum product function. So it depends on what you want to do. You can put different way. Okay, so I'll do the sum product. Here the unit produced and unit cost, or gives me the production cost. Or sometimes the company would may want to know the monthly production cost and the monthly inventory cost. So instead of doing this, the sum products, what you can do is also just do unit produced multiply unit cost and copy it all the way. Then here I will change this to be monthly production cost. So this way we present more information to the company. Okay, monthly inventory cost, and here will be the same. We're going to use average inventory multiply. Did I? Okay, here equals to be average inventory multiply unit and inventory cost. Here, just okay. Those numbers are too long to show, but it's okay. That's because we don't have any value here. Then I'm going to put the total cost here. This total cost will be just the one cell. That equals to be sum of all the values here. Okay. Finally, we got our objective function. I'm going to highlight it. That's the objective. Now we'll take care of those constraints. Go back. First constraint, production level. So we have the capacity and half of the capacity. So let's just put it. So here, we got that here. So maximum production. That's one of the constraints, and we'll calculate the minimum production. Being half. So here you can either put a 0.5 here, or just this is probably one time. I would just embed the formula here, equals to be 0.5 multiply those values. Okay, that's just for the purpose that that equals to this times this 0.5 here, and this 0.5 need to be fixed. So this helps us to calculate of them are the half of the maximum production. And these will be used as the right hand side of my constraint. I'll just highlight them. The left hand side are all of our decision variables. So that's two constraints. And then we know that the next thing is the inventory. We had a group of constraints. Inventory minimum will be 1,500 and the maximum will be 6,000. That's the same for all 6 months. So to put them in the same format, I'll just put here minimum. No, sorry, maximum inventory and the minimum inventory. So the maximum inventory is 6,000. This is a given. Minimum is 1500. Just copy it across. Okay, and these will be my right hand side too. Okay, with that, we took care of all the constraints. Those really obvious constraints are just those two groups. The monthly production cannot exceed the capacity and should be more than half of the maximum capacity. And the inventory need to be between 1,500 and 6,000. And the other constraint that we defined are the relationship between the inventory, production, and the demand. Okay, so that's the model. And just to make it look better, because all of these parts are calculating the product, like the unit cost, the monthly cost. I'm going to just move them here. So I'm going to shift this table here. The reason is that I just want my total cost cell at the bottom here. So I don't like it to be in the middle somewhere in the model. Okay, so it's down here. So you look at the entire thing. So that's the production and inventory relationship table, and here are those constraints that you have to satisfy. Here are some unit costs, and eventually gives you the total cost. So it will read nicely this way. Okay, then let's go to define solver. So go to solver, reset all. Okay, objective, this one, maximize it. Oh, sorry, minimize it. Okay. Minimize total cost. Okay, by changing those variables here. Okay, and the constraints you have will be, so the decision variables need to be less than or equal to the maximum production at decision variables need to be greater than or equal to minimum production. So that's the production part. The left hand side are the unit produced, the decision variables. Right hand side will be these two rows. First row will be less than or equal to, second row will be greater than or equal to. Let me know if I'm going too fast. Okay. Then would be the inventory part. And you find that we are talking about the ending inventory, right? At the end of each month. So we need to highlight this part. So it should be less than or equal to the 6,000 and the ending inventory need to be written equal to this 1500 like here. So if you look at, they're just these two groups, and these two groups are the bounds. So you probably have noticed that even though when we define the constraint, we just click constraint add, the solver actually categorize those constraints for us. Okay, and here we don't need to check this unconstrained variable, non-negative, because they are already bounded here. Let me ask you, by just observing that, what are the bound constraints? What are those bounds? Bounds of what? Those are bounds of the, what's the C8 through H8? No, in terms of the model, the decision variables, right? Okay, so those bound constraints represent the lower or upper limits on your decision variables. Okay, so if you ever set upper limit or lower limit on your decision variables, they will shown here as the bound. Okay, and the other will be like a normal constraints. Okay, then here, change it to the LP algorithm. Oh, I clicked the wrong button. Cancel. And the solve. Okay, so we find the solution. All constraint opportunity conditions are satisfied. Okay, and we find it. I'm just going to add all of them. Okay, then you can do the cosmetic work yourself. For example, here I use the two column. I'll just add a border like this. Here, no border and then outside bar, so they are all together. And same for these ones, and all of those ones can be bold and lined. Total cost, that's the objective function. Cell, I'm going to just add a sig border to it. And these ones, add a border for those ones. Same with those ones. No border and then just the outside bar. Total cost. Okay. Then you can add a box here, text box here, just to put like the title of this spreadsheet. Then you have a nice and clean spreadsheet that reads pretty well. So you read it, the beginning inventory, produced unit, demand, and inventory. Then we calculate, oh I forgot this part. We calculated the average inventory. And we have those restrictions on it. Then we calculate the unit cost, then the total cost. Monthly production cost, monthly inventory cost, and the total cost. Okay. And make sure, do you guys know how to add the tab? So make sure, like for the homework that you're going to turn in next week, you put all the models on one Excel spreadsheet. Okay, but just put them on different tab. I've got students turning like 6 different Excel file to me, having a question on each file, but turning just one file with them on different tabs.
I'm not looking for constraints on getting the wrong answer.
So these are the only constraints. Constraint for this problem is pretty straightforward, right? Probably just like check if you did the correct. If you did correctly in those formulas here, did you link them correctly? Yeah, because I think the constraints in this problem is pretty straightforward. Just less than equal to, greater than equal to those minimum maximum. Or see if you refer to the right cell for the left hand side of your constraint. The first group constraint would be the decision variables, the left hand side. Second should be referring to the ending inventory. Check to see if you didn't get correctly, check if you refer to the right inventory. Should be the ending inventory, not the beginning, not the average. So check those ones too. Okay. Okay, so let's see. And just finish.